Okay, let's start. So topic for today's lab is standing waves and the speed of sound. Did you talk about the harmonic mode, the standing waves in lecture?
Yeah, we talked about
Talk about it, right? So, okay, that's good. You didn't. Yeah, depends on different structure, but no worry. I will tell you what equations to remember, what equation you will use. So the most important equation is this equation. Let me write down this equation and then we will introduce what there are three, right? Lambda, F, and V, what each represents. So this is the most important equation. So lambda is called wavelength. So later I will introduce how to calculate the wavelength. So here you just remember it is wavelength. F is the frequency. And also wavelength length, right? The unit is meter. Frequency, what's the unit for frequency?
hertz.
Yes. So in the experiment, you will read the frequency from the controller. So when you turn it on, you can read the frequency. And V is the velocity. Velocity. That's the wave propagation velocity. So that's this equation. Next, so in your pre-lab, you did this one, right? Ask you to calculate the wavelength. So one wavelength is this is a sine wave, right? So a full sine wave is one wavelength, that is one lambda, right? So what we do is that we measure this distance, and also we know because this is one wavelength. So lambda equals L in this case. How about in this case? If we of course we can measure this distance L. So but here there is only half, right? So we have this equation, lambda over 2, because this is only half wavelength equals L. So based on this equation, we can calculate lambda, right? Lambda equals 2 times L, because we can measure the L. So how about pre-lab question 1? How did you calculate the wavelength? So pre-lab question 1, the length of the string in the below picture is 3.6 meters. So from here to here is 3.6 meters, that is L. Then we take a look how many lambda. This is 1 lambda, 2 lambda, 2.5 lambda, right? So that 2.5 lambda equals 3.6 meters. Then you can calculate lambda, right? 3.6 over 2.5. What did you get? It's 1.44 meters, right? That's the lambda. This is the answer for pre-lab question 1. Pre-lab question 2 is, what is the next condition on wavelength for the standing wave of sound in a tube of length L? In this case, what would be the wavelength of the sound wave if the tube is 70 meters long? If the wave speed of sound is 340 meters per second, what is the frequency? Let's take a look at this one. So this is lambda over 4, 3 lambda over 4, 5 lambda over 4. So the next one is 7 lambda over 4. So that the next one is 7 over 4 lambda equals L. And we know the L. because the L is 70 centimeters. So that based on this one, we can calculate this lambda equals 0.4 meter. Next, so if the wave speed of sound is 340 meters, what is the frequency? Can you calculate the frequency? Remember this equation, right? V equals lambda times F. Here we obtained lambda, which is 0.4, but we do not know the frequency, but give you the velocity, which is 340 meters per second, right? Then the frequency, F equals 340 over 0.4, which gives you 850 hertz. That's this one. So these are the pre-lab questions. So the most important equation is this equation. Velocity equals lambda times F. So let's take a look at the procedures. We have two procedures today. The first procedure is the standing wave of a string. So here, this is the string, and we add a mass here. We can try different mass. So, and then this is the vibration source. By turning on this controller, you can see this is the frequency of vibration, and also you can change the amplitude, and also you can change the frequency. This is that 1 hertz. And by adjusting the frequency, you would be able to see the standing wave on the string. And based on the how many wavelengths it is, because you will use your ruler to measure the length of your string. Okay, turn it off. So measure the length of the string from the source of the vibration to here. So you do not measure this distance, measure this distance from the source of the vibration to the pulley. So this is L, right? So you can measure L. Measure length of the string, that is in meters, convert this one to meters. And then turn on the controller, and you will be able to see the shape of the waveform and see how many wavelengths it is. And then based on the pre-lab question 1, right, you can calculate the wavelengths. This is how you get the wavelengths. Next, this equation is given. The wave speed of a wave in a string is determined by this equation. So because this wave is not propagated in air, so it is not 340, right? This wave is propagated along the string. So we have this equation to determine the velocity, which is V equals the square root of T over mu. What is T? T is the tension of the string. So how can we find the value of T? It depends on the mass, right? Mass determines the tension is based on this mass. So you can calculate T based on your mass. But remember, convert the grams into kilograms and then multiply 9.8 to get the tension. And next, in this procedure, you need to calculate mu. What is mu? Mu is the mass per length of the string. So here, T is the tension of the string. Mu is the mass per length of the string. So you need to calculate mu. How do you calculate mu? So you need to use two equations. The first equation is lambda f equals v. Right, now you are familiar with this equation. We square both sides, so you have lambda squared and f squared. No, not this one. No, this one. This equals v. V equals that one, equation 2, right? Equals the square root of t over v. Right, based on this equation, you square both sides, t over v. And then you have this equation, right? Then what is mu? Mu equals t over lambda. Right, this is how you calculate mu. And also you can first, you know the lambda, you know the f, so you can calculate v. Once you obtain the value of v, you can calculate mu. Mu also equal, because v squared equals t over mu, right? So mu also equals t over v squared. These two equations are the same because lambda times f equals v, right? So lambda squared times f squared equals v squared. You can use either equation, this one or this one, both works. So this is how you find mu. Mu, the physical meaning of mu, is the mass per length of the string. So in this experiment, in this procedure, just you can try different combinations of frequency and mass. So you can change the frequency. When you change the frequency, the shape of the wave will change, which means that the number of wavelengths will change, but L will not change. This L is always the same, right? For example, here you have 2 lambda equals L, but when you change the frequency, you may have maybe 5 lambda equals L, so that the lambda changes, and also the frequency also changes because you can read the frequency from here, right? But approximately this V is almost the same. So that is the V equals lambda times F. So the V is almost the same. So you will repeat the experiment several times. Each time you can calculate the value of mu and then take the average. I think you are asked to do the experiment for 3 different, you can do 3 different frequencies and fill in these 3 rows so that each trial you can get 1 mu value and then take the average. So this is procedure 1. And then the discussion question 1 is use the electronic balance to measure the mass of your string and find its length and compute mu equals m over v, or m over L. So this is the theoretical value of mu. So what you do is that you remove the string from the vibration source and measure the mass using the scale. And then that is m, right? That is m. And then use the ruler to measure the total length. Here the total length is, this is the total length, this is L. So this L is different from the previous L. So this is procedure 1. The procedure 2, procedure 1 is very important because in previous years they ask you to repeat procedure 1 for the final exam. So make sure everyone know how to do the experiment. And procedure 2 is the standing wave in a tube. So this is the tube, this is the speaker, right? So what you do is that there are two wires from the controller connect the two wires with the speaker and connect the speaker with the tube and adjust the frequency from 0 and gradually increase the frequency. And you will find that the volume from the tube will increase and then decrease. You record the frequency which the volume is the highest. So this is I provided the template. I think did you find the template canvas? Yes. So for procedure 2, of course you need to measure the length of the tube and the diameter of the tube. Based on these two, you can calculate L. So there is some correction on the L, which is the length of the tube plus 0.3 times the diameter of the tube. And then find the frequency where the volume is the loudest, record the frequency. Based on the frequency, and also you know the velocity because it is propagated in air, the sound, 340, right? So, and then based on these two, you can find the lambda. And based on lambda, you have this plot. Use the frequency for the y-axis. Use the 1 over lambda. Oh no, so this one. Calculate lambda. Do not use the velocity because later you will find the velocity. So here assume you do not know the velocity. And then so plot the frequency versus 1 over lambda, and the slope is the velocity, right? Because this equation equals v, right? So that so frequency equals 1 over lambda times v. So you plot the frequency for the y-axis, plot 1 over lambda for the x-axis, then the slope is your velocity. So the theoretical value is 340 or something. So that's these two procedures. Now I think you are able to start.